The electrical inspector is requesting ground fault circuit interrupter (GFI) protection for the water feature due to safety concerns. There have been incidents of drownings and near drownings related to the absence of GFI protection in swim ponds and similar water features. While the National Electrical Code (NEC) may not explicitly address man-made creeks, the primary concern is that it is a body of water. Those responsible for constructing such features must ensure a safe environment for users. The NEC mandates GFI protection for swimming pools, spas, hot tubs, and similar installations. In the 2008 NEC, GFI protection became mandatory for any body of water, whether natural or man-made, specifically intended for swimming or bathing. Compliance with the NEC requires the installation of a GFI protected circuit for the water feature. This measure is essential for ensuring the safety of both the property owner and the guests. Ground fault circuit interrupters, or GFIs, are crucial safety devices designed to protect individuals from electrical shock hazards. They operate by monitoring the balance of electrical current flowing through a circuit. In a properly functioning circuit, the current flowing into the circuit should equal the current returning. A GFI continuously monitors this balance. If a difference in current is detected, even as small as 5 mA, it indicates that some of the current is leaking to ground, potentially through a person. When this leakage is detected, the GFI quickly trips the circuit, cutting off the power and preventing a dangerous electrical shock. The speed at which a GFI operates is critical. It typically trips within a fraction of a second, often as little as 1/40th of a second, which is fast enough to prevent serious injury. This rapid response is what makes GFI so effective at preventing electrocution. GFI are commonly installed in areas where electrical outlets are near water sources, such as bathrooms, kitchens, and outdoor locations. They are also required in construction sites and other areas where electrical equipment may be exposed to moisture or damage. There are two main types of GFI: receptacle type GFI, which are installed in place of standard electrical outlets, and circuit breaker type GFI, which are installed in the electrical panel. Both types provide the same level of protection. Regular testing of GFI is essential to ensure they are functioning properly. Most GFI have a test button that, when pressed, simulates a ground fault condition and causes the GFI to trip. It is recommended to test GFI monthly. If a GFI fails to trip when tested, it should be replaced immediately. GFI protection is vital in locations where water and electricity are present. Water significantly reduces the resistance of the human body, making it easier for electricity to flow through a person, leading to severe shock or electrocution. By quickly interrupting the circuit when a ground fault is detected, GFI significantly reduce the risk of electrical shock hazards. This is especially important in areas such as swimming pools, spas, and man-made creeks, where people are likely to be in direct contact with water. In the context of the specific situation involving the man-made creek at the resort, GFI protection is paramount to safeguard the well-being of guests who may come into contact with the water. The 460-volt, 60-amp three-phase service powering the water feature presents a significant electrical hazard if not properly protected. A ground fault in such a system could result in a substantial flow of current through water, posing a serious threat to anyone in or near the creek. Therefore, the electrical inspector's insistence on GFI protection is not only in compliance with electrical codes but also a crucial safety measure to prevent potential accidents and injuries. The NEC provides detailed guidelines on the installation and use of GFI in various applications. Article 680 of the NEC specifically addresses electrical safety requirements for swimming pools, spas, hot tubs, and similar installations. While the code may not explicitly mention man-made creeks, the intent is clear to protect individuals from electrical hazards in and around bodies of water. The requirements include GFI protection for outlets, lighting, and equipment located near the water. These regulations are designed to minimize the risk of electrical shock and ensure a safe environment for users. In addition to GFI protection, other safety measures should be considered for the water feature. These may include proper grounding of all electrical equipment, using low-voltage lighting systems, and installing warning signs to alert guests to potential electrical hazards. Regular inspections and maintenance of the electrical system are also essential to identify and address any issues before they become a safety concern. Engaging a qualified electrician to perform the installation and maintenance work is highly recommended. A licensed electrician has the knowledge and experience to ensure that the electrical system meets all applicable codes and standards. They can also provide guidance on the best practices for electrical safety in and around the water feature. Furthermore, it's important to educate guests about electrical safety and encourage them to report any potential hazards they may observe. Clear communication and awareness can significantly reduce the risk of accidents and ensure that everyone can enjoy the water feature safely. Compliance with the NEC is not only a legal requirement but also a moral obligation to protect the safety of guests and employees. By implementing GFI protection and other safety measures, the resort can demonstrate its commitment to providing a safe and enjoyable environment for everyone. This proactive approach can help prevent accidents, reduce liability, and enhance the resort's reputation. In summary, GFI protection is essential for the man-made creek at the resort to mitigate the risk of electrical shock hazards. Compliance with the NEC, proper installation and maintenance, and guest education are all crucial components of a comprehensive electrical safety program. By taking these steps, the resort can create a safe and enjoyable experience for all who use the water feature. Additional considerations include the selection of appropriate GFI devices. The devices must be rated for the voltage and current of the circuit they are protecting. In this case, a 460-volt, 60-amp GFI circuit breaker would be required. These breakers are typically more expensive than standard circuit breakers, but the added protection they provide is well worth the investment. Furthermore, the installation location of the GFI device should be carefully considered. It should be readily accessible for testing and maintenance, but also protected from the elements. A weatherproof enclosure may be necessary to ensure the longevity and reliability of the device. The wiring of the circuit must also be in accordance with the NEC. This includes using the correct wire size, proper grounding techniques, and appropriate conduit for protection. A qualified electrician should perform the wiring to ensure that it is done safely and correctly. Regular inspections of the wiring and GFI device should be conducted to identify any signs of damage or wear. Any issues should be addressed promptly to prevent potential electrical hazards. In addition to GFI protection, consider other safety measures such as emergency shut-off switches. These switches allow for the immediate deactivation of the electrical system in case of an emergency. They should be located in easily accessible locations near the water feature. Signage is also important to inform guests of the potential hazards and safety precautions. Signs should be posted in multiple locations around the water feature, warning of the dangers of electricity and advising guests to avoid contact with electrical equipment. Lighting around the water feature should be designed to minimize glare and provide adequate illumination for safe navigation. Low-voltage lighting systems are preferred as they reduce the risk of electrical shock. The placement of lighting fixtures should be carefully considered to avoid creating shadows or blind spots. Employee training is also an essential component of a comprehensive safety program. Employees should be trained to recognize potential electrical hazards and to respond appropriately in case of an emergency. They should also be trained on the proper use of emergency shut-off switches and other safety equipment. Regular safety drills should be conducted to ensure that employees are prepared to handle any situation. Finally, it's important to maintain accurate records of all inspections, maintenance, and repairs. These records can be used to track the performance of the electrical system and to identify any recurring issues. They can also be valuable in the event of an accident or investigation. By implementing these additional safety measures, the resort can further enhance the safety of the water feature and minimize the risk of electrical accidents. Remember, safety is an ongoing process, and continuous improvement is essential to ensure the well-being of guests and employees. The importance of grounding cannot be overstated. Grounding provides a safe path for fault current to flow back to the source, tripping the circuit breaker or GFI and preventing electrical shock. All metallic parts of the electrical system, including conduit, enclosures, and equipment, must be properly grounded. The grounding electrode system should be installed in accordance with the NEC and should be regularly inspected to ensure its integrity. Surge protection is another important consideration, especially in areas prone to lightning strikes. Surge protective devices, or SPDs, can help protect sensitive electronic equipment from damage caused by voltage surges. SPD should be installed at the service entrance and the branch circuits to provide comprehensive surge protection. Electrical panels should be properly labeled to identify the circuits and equipment they serve. This can help prevent confusion and ensure that the correct circuit is to energize during maintenance or repairs. The labels should be durable and easy to read. Regular cleaning of electrical equipment is also important to prevent the buildup of dust and debris, which can cause overheating and electrical failures. The equipment should be de-energized before cleaning, and appropriate cleaning methods should be used. Avoid using water or other liquids that could create an electrical hazard. The use of extension cords should be minimized, as they can be a tripping hazard and can overload circuits. If extension cords are necessary, they should be heavy-duty and properly sized for the load they are serving. They should also be inspected regularly for damage and replaced if necessary. Electrical work should only be performed by qualified electricians who are licensed and insured. Attempting to perform electrical work without the proper training and experience can be dangerous and can violate electrical codes. Permits may be required for certain types of electrical work, so it's important to check with the local authorities before starting any project. The NEC is constantly evolving to address new technologies and safety concerns. It's important to stay up to date with the latest revisions and to ensure that the electrical system complies with the current code requirements. Local authorities may have additional requirements that go beyond the NEC, so it's important to check with them as well. Electrical safety is a shared responsibility, and everyone should be aware of the potential hazards and take steps to prevent accidents. By following these guidelines and working together, we can create a safer environment for all. Remember to consult with a qualified electrician for specific guidance on your electrical system and to ensure that all work is performed in accordance with applicable codes and standards. Do not attempt to perform electrical work unless you are properly trained and qualified. Your safety and the safety of others depend on it. The electrical system is a critical component of any building, and it's essential to ensure that it is properly designed, installed, and maintained. Regular inspections and maintenance can help prevent problems and ensure that the system operates safely and efficiently. A well-maintained electrical system can also save energy and reduce operating costs. Consider implementing a preventive maintenance program that includes regular inspections, testing, and cleaning of electrical equipment. This program should be tailored to the specific needs of the facility and should be performed by qualified personnel. The program should also include documentation of all inspections, maintenance, and repairs. This documentation can be valuable for tracking the performance of the electrical system and for identifying any recurring issues. Electrical safety audits can also be conducted to identify potential hazards and to ensure that the electrical system complies with applicable codes and standards. These audits should be performed by qualified professionals who have experience in electrical safety. The results of the audit should be used to develop a plan to address any identified issues. Emergency preparedness is also an important consideration. Develop an emergency plan that outlines the procedures to be followed in the event of an electrical emergency. This plan should include information on how to shut off the power, how to evacuate the building, and how to contact emergency services. The plan should be communicated to all employees and should be practiced regularly. Electrical fires are a serious hazard, and it's important to have a fire extinguisher readily available in case of an electrical fire. The fire extinguisher should be rated for electrical fires and should be used according to the manufacturer's instructions. Do not use water to extinguish an electrical fire, as this can create an electrical shock hazard. Carbon monoxide detectors should also be installed in buildings with electrical equipment. Carbon monoxide is a colorless, odorless gas that can be produced by malfunctioning electrical equipment. Carbon monoxide poisoning can be fatal, so it's important to have detectors installed to alert occupants to the presence of carbon monoxide. Finally, remember that electrical safety is an ongoing process and that continuous improvement is essential to ensure the well-being of guests and employees. Stay informed about the latest electrical safety standards and best practices and implement them in the workplace. By working together, we can create a safer environment for all. Remember, always consult with a qualified electrician for specific guidance on your electrical system and to ensure that all work is performed in accordance with applicable codes and standards. Your safety and the safety of others depend on it.